Hi guys, this is Ishan Sharma. I will explain the Mapreduce concept and its working in Hadoop. As name suggests, here we are mapping something that is data and then reducing it. Now, before looking at the definition, we must know what parallel and distributed algorithm is. Let's take an example of making a burger, since everybody knows what it is inside a burger. So suppose you have 4 chefs and each chef takes 1 out of 4 jobs, that is chopping salad, preparing bun, making sauce and frying tikki, and at last combining each task to make a delicious mouth-watering burger. This is how task is distributed parallelly. Now suppose each chef has allocated the task to his junior chefs, then this is called distributing the task. In technical terms, if devices are different, we use parallel algorithm, and if devices are same and processors are separate, then we use distributed algorithm. Now we can come to MapReduce definition now. That MapReduce is a model and implementation of parallel and distributed algos on connected computers called as clusters for processing large data and reducing it to useful results. Now we can understand what exactly map procedure is with the help of last example, that converting raw materials into useful contents. See an example of making tikki from potatoes. That is, we can say as a map procedure. And reduced procedure is when all contents are combined to form a burger. Map procedure runs parallelly and reduced procedure may run parallelly, or it may be a single procedure which solely depends on algorithm programmer decides. Now we will see an overview of how MapReduce work in Hadoop. Name node is a master service. As you can see, it's like a pointer which stores metadata and block reports from the systems. Here jobconf is user interface that tells what is the job of MapReduce. Job tracker is a master service which allocates tasks to task tracker and maintains block reports. The task tracker is slave service which accepts tasks from job tracker and processes it on a data in job tracker and sends heartbeat to job tracker, that is it alive or not. Now we will take an example to show its working. Here let's suppose job tracker is like a police officer, name node is like a surveillance department, and task tracker is like a area constable. Now I am in Delhi and my car is stolen. Suppose I call the police officer to find it. He will first request the surveillance department to give records of surveillance cameras. On that basis, police officer assigns tasks to the area constables to search it. Constable starts search on his area, which is called map procedure, and some output is given by him. Now all constables produces some output which is collected and reduced. On that he finds my car. Like that only the task tracker, job tracker work in Hadoop engine. Now you can see what are the primary functions of job tracker and task tracker are. The primary function of job tracker is resource management, and the primary function of task tracker is following orders of job tracker. Also here, task tracker is pre-configured with a number of slots which can accept multiple tasks, and if the slots are not empty, this is indicated to the job tracker, and the job tracker will send the task to some other task tracker. Now comes fault tolerance. The task tracker opens child processes like JVM processes, which are used at the time when any single child is down. The task tracker will be running. It will not be down. The task tracker keeps sending heartbeat messages to job tracker to say that it is alive or not. And also it sends some block reports that shows are there any number of empty slots to process some other tasks or not. From version 0.21 of Hadoop, the job tracker does some checkpointing which are like a snapshot and that are used at a time when there is a system failure. Now before heading to the word count job of MapReduce engine, you should know some basics. Now there are basic allowable text file formats which are listed here, that is text input format, key value text input format, sequence file input format, and sequence file as text input format. These are some basic allowable file formats which are read in this MapReduce engine. Now comes box class types. In Java, there were primitive class data types like int, float, long, char, string. In Hadoop, we use int writable, float writable, long writable text respectively. The box classes implement writable interface and writable comparable interface. Now this comparable interface is used to compare the values, as we will be dealing with keys, so they have to be compared first at the time of sorting, which you will come to know in the later stages. Now comes word count job. Here you can see a 200 MB input file which is divided into 64, 64, 64 and 8 MB divisions. This is to be applied to the Mapreduce engine. Let us suppose we take text input format file. The input file is split into input splits. Record reader reads the input line by line and converts it into byte offset, entire line pair. Here byte offset is address of the first letter of first word, that is 0. Then again record reader reads the data from input split and makes it to key value pair. This is applied to mapper which is programmed by user only, and it converts this key value to some other key value pair, and we get intermediate data. The process continues till all the lines are read. Now comes shuffling process. See here, what is a key and one is value here. Since this is key, it can't be redundant, that is, it can't be duplicate. So shuffling deals with all these types of redundancies. Then shuffled key value pairs are sorted, and here as you can see the key value compared, for which writable comparable interface was needed, as I told you earlier. Now comes reducer into play, where it takes these key value pairs and from there record writer writes output to output file, which is named as part 40 in Hadoop. Fields where MapReduce can be implemented are: first is distributed pattern based searching, where large sets are dealt and some pattern is searched from these large sets. Second comes distributed sorting. Here we can take an example of quicksort, where we split and recombine the input or an array we take. Then third comes web link graph reversal. Here we deal with incoming and outgoing links on our web page. If suppose there are only outgoing links, then we use map and reduce concept accordingly. Fourth comes web access log stats. MapReduce is used to derive key information from access logs. Now fifth comes document clustering. It is used for automatic document organization, topic extraction, and fast information retrieval or filtering. And the last is statistical machine translation, where one language is translated to another language. Next are the limitations of MapReduce. Now, as we know, it's a complicated process, so it is not always feasible to implement the MapReduce. In a situation where intermediate processes need to talk to each other, it can't be possible because these processes run in isolation. When your processing requires a lot of data shuffling over network, this is also the condition where MapReduce can't be implemented. The fundamentals of Hadoop were not designed interactive analytics. When it was implemented, it was not as interactive as now it's becoming day by day. The answer you get are not 100% accurate, and it solely depends on the job you give to the Hadoop engine. Last point is multiple copies of already big data. If you have a 1 petabyte of data and you are creating 3 copies, then it is around 4 petabytes stored in your servers. It is just consuming your space, right? This is also a limitation of MapReduce. Thanks for watching, guys.